Today we're going to talk about how to make predictions based on results that are recorded within a table. Let's look at this first problem. The table below shows the number of votes for students' favorite shapes. Based on the information in the table, what is the most reasonable prediction of the number of votes for Pentagon out of the next 30 votes? So the first thing that I do is I need to go back and I need to look at what is the important information from this problem. Within this question, I can see, reasonable prediction. And we're talking about the Pentagon, so I'm going to want to circle my information in the table about the Pentagon. And then it's also asking for that prediction to be out of the next 30 votes. Whenever we are looking at making a prediction, we need to make two separate fractions. So the first fraction we need to make is based on what really happened. So we can see that the Pentagon was selected 33 times. That's going to become our numerator. In order to determine my denominator, I'm going to have to figure out what was the total number of votes. So I need to take a sum of all of the votes from the table. Well, I know that 3 and 7 make a 10. The other 3 and 7 make a 10 as well. So the sum of that ones column is 20. Then in the tens column, 2 and 3 make 5, plus 3 and 1 more are going to be 9. So the total number of votes were 90. So that becomes my denominator. Now I'm going to make a fraction for my prediction. I can see that they want the prediction to be out of the next 30 votes. So I'm going to go ahead and use that as my new denominator. You can think of it, this is the next fraction, and it's out of the next 30 votes. So then we're just looking at a relationship because we need to create an equivalent fraction. So what's the relationship between 90 and 30? Well, 90 divided by 3 is 30. So I'm going to need to divide my numerator, by 3 as well. 33 divided by 3 is 11. So a reasonable prediction is that there will be 11 votes for Pentagon out of the next 30. Now let's go ahead and look at another problem that is similar but is different as well. Let's look at another problem. Ethan pulled colored tiles from a bag. The table below shows the number of times he selected each color. Based on the table, which statement about the next drawing is not true? A, he is twice as likely, that means 2 times as likely, to pull out a red tile than a yellow tile. Well, let's go ahead and see. How many red tiles were there? There were 12. And we need to examine the table to see how many yellow tiles there were. There were 6. Is red 2 times 6? Is 12 2 times 6? Yes, so this one is a true statement. B, he is more likely to pull a green tile than a yellow tile. So let's look at our table again. We can see that green, there were 8 tiles, and yellow, there were 6 tiles. Is he more likely to pull a green than a yellow? Yes, he absolutely is. So that is true as well. C, he is 3 times more likely to pull out a blue tile than a green tile. Blue tiles, there were 18 that were selected. And green tiles, there were 8. Is 18 equal to 3 times 8? No, it is not. So this relationship is false. That's our false statement. Let's go ahead and examine D because we need to go through each of our answer choices, even if we think we've already found the correct answer. He is more likely to pull out a red tile than a green or orange tile. So red tile, we can see that there were 12. And I want to know, is that more likely than the other option? Now when I see green or orange, I'm going to combine my results for green and orange. So I'm going to add 8 plus 2, which is equivalent to 10. Is 12 greater than 10? Yes, it sure is. So he is more likely to pull a red than a green or orange tile. So you can see that the correct answer for this problem is C.